Good morning, everyone. Today we're going to look at linear relations and how to tell if a table of values that you're given is a linear relation, or even a situation or an equation is a linear relation. So this is linear relations. Okay, so let's first talk about the situation of me driving home from, let's say, Mississauga. Okay, so I'm driving home and I'm taking my time. I'm going on the not the 401, but some back roads, and I'm going to take about 4 hours to get home from Mississauga, which is a long time. So my time, I'm recording it in hours, and my distance from home is in kilometers. Okay, so let's say that my time, we're gonna take 4 hours to get home. So we're gonna start at time 0. We're gonna go time 1, time 2, time 3, and time 4 hours at home. And at 4 hours, I am at home. Okay, Mississauga is about 320 kilometers away. So at hour 0, I'm 320 kilometers away from my house. At hour 1, I look it up and I see that I'm 240 kilometers away. At hour 2, I'm 160 kilometers away. At hour 3, I'm 80 kilometers away. And at hour 4, I pull into my driveway and I am home. So the question would be is this a linear relation? Well, how do we tell that? So let's take a look at the characteristics of a linear function to begin with. So we have here the linear function. And we know we have 4 different ways to represent our linear function. We have a graph, we have a situation, we have an equation, and we have table of values. So the graph, first of all. Well, how do we tell if a graph is a linear function? The graph would be about the easiest one. What you're looking for in a graph, it's a line. So your graph will just be any sort of straight line, any what way, whether it be the red or the blue. Those graphs are linear relations because they form a straight line. Well, the situation we had the other day was Jillian at the gymnastics club. And Jillian was working at gymnastics club, and she was making a constant rate of change. A constant rate of change is just something that's changing at a constant rate. I know I pretty much just described the exact same thing. By the way, I'm going to call my rate of change an ROC from now on. Okay, so in Jillian's first case was working at gymnastics, the Chatham Gymnastics Club, and she was making $20 per hour. The constant rate of change there was the $20 per hour. Every hour she made $20. It didn't go up after 2 hours. It's not like she made $30 an hour after 2 hours, or it's not like she made $15 an hour after 2 hours. She always made $20 an hour. In the Blenheim Gym Club, she made less money, but she got $20 to show up, and then she made $15 per hour. So every hour she made $15. So it remained the same the whole way. So let's take a look at the equation. Okay, so the Chatham Gym Club, she made, I wish I didn't write table of values here. Let me take that out for a minute. She made, her money was equal to, the Chatham Gym Club paid her $0 to show up, plus $15 per hour. Okay? So in the equation for a linear relation, we are looking for a number, which would be your rate of change, times a variable. So at 1 hour, 15. At 2 hours, 15 times 2, $30. At 3 hours, 15 times 3, $45. Okay? In the Blenheim Gym Club situation, she made $20 just to show up. The $20 was a one-time fee. She didn't get it every hour. She just got it when she showed up. Okay? So she showed up, she got $20 an hour. I'm really sorry. The Chatham Gym Club, she got $20 an hour. Okay? The Blenheim Gym Club, she got $15 per hour. Okay? So that is what's changing every single hour is the 15. Okay? So in the equation, this is why I took this out, you're going to have your dependent variable, let's call it y, is equal to your initial value plus your rate of change times your independent variable, and we'll call it x. That's the general thing. Initial value, rate of change. Dependent is equal to your initial value plus or minus your rate of change times x. Okay? And the table of values. Well, let's go into that. How do we tell if a table of values is linear? Well, the table of values, we're looking for the same thing. We're looking for a constant rate of change. So how do we find a constant rate of change? Okay, let's go over here and let's take a look. So first thing you need to know is you have to look at your independent. Your independent's always on the left, or it'll be on the top if it's written horizontally. So your independent has to be going up by the same amount. 0, 1, from 1 to 2 it's up 1, from 2 to 3 it's up 1, from 3 to 4 it's up 1. And if it is going up by the same amount, well then we can look at a constant rate of change. Let's see how we get from 320 to 240. Well, how did we get from 320 to 320 to 240? We went down 80 kilometers. How do we get from 240 to 160? We went down represented by negative, 80 kilometers. How do we get from 160 to 80? Again, we go down 80 kilometers. And how do we go from 80 to 0? Again, we go down 80 kilometers. This right here, the change in my dependent variable is my constant rate of change. So we know that this function of me driving home from Mississauga, which is 320 kilometers away, is a constant, it's a linear relation. Okay? We can get into what does that 80 mean later. But let's try to show it on a graph, just to confirm. I don't have a line, so I don't have a ruler right now, so I'm doing my best. Okay? So I have time of 4 hours. 0, 1 hour, 2 hours, 3 hours, 4 hours. Okay? So now I want to go up. I need my graph to go up to 320. So let's take a look at this. If that's 100, 200, 300 and a bit, I can maybe go threes. No, I think that would be good. 100, 200, 300. And again, every one line is 50, so that I'm going to put 350 in there just so we can find our 320. Okay, so let's graph this. At 0 hours, she is at 320. So we're going to start right about there. At 1 hour, she is at 240. So there's 250. We're going to be one right about here. At 2 hours, she is at, sorry, why I keep saying she? Me. I am at 160. So right there, 2 hours, there's 150. That's about 160 right there. At 3 hours, I am at 80, which will be right about there. And at 4 hours, I am at 0. I'm at home. Okay? You can see this is a line. I'm looking around for anything that would resemble a ruler. I have a block of wood. Hopefully you have a ruler at home. Next time I might be a bit more prepared. Okay, let's see if I can draw this. Perfect. So you can see here I do have a linear relation. Okay, hope that helps. I'll assign some work for you guys and make sure you get in touch with me or Miss Nicholson if you have any questions.